Hello, my name is Scott Schenker, and on behalf of my 8 esteemed co-authors, I will be talking about a public option for the core. I should warn you that this is not a standard paper or talk. Most SIGCOMM papers start with a very clean problem and then present a solution with very clear performance metrics that they can evaluate. The issue we address here is much more amorphous, so the solution is harder to evaluate. As a result, this talk will be more conceptual than purely technical. I think I've got one equation. And because it's being delivered by an academic fossil, it is a very completely retro talk with no graphics, just words. I should start off by making a distinction between technology, architecture, and infrastructure. Now, technology is how routers and links are built. This is something I've never understood, so this is not what the talk is about. Architecture is something we all love to think about. It involves layering, the narrow waist, best effort. And the architecture was a result of much thought and deep insight, like the end-to-end principle. And more importantly, as a community, we've had active discussion about clean slate alternatives. So our understanding of the architecture arises not just from studying the architecture directly, but understanding how it fits into the ecosystem of alternatives. But this talk is not about architecture either. It is about infrastructure, by which I mean the domain structure, peering and transit, how we've organized the nature of internet delivery from a bunch of supporting institutions. Our existing infrastructure was really much more an accident of history than a carefully thought out design, and it has many problems. But there's been little discussion in our community about alternative ways of organizing this. Yes, we've considered different designs for BGP and the like, but the basic economic structure, we haven't really considered that deeply. This is what we consider in this talk and in this paper. And in the talk, I'm going to motivate our proposal by discussing 3 particular problems with the infrastructure. The paper addresses a slightly larger set of issues. Problem number 1 is the privatization of transit. Most traffic now, in the paper we say, perhaps as much as 70%, goes straight from origin domain to destination domain without any transit on the public internet. And Jeff Houston has written about this. Now, that's not that no packets are getting transit. It's just that the transit has been moved to these private networks. I should point out that CDNs, of course, and other edge processing reduce the backbone traffic compared to if they weren't used at all, but there is still a lot of transit traffic. It's just on private networks. And these private networks are not a bad thing. They enhance customer experience. The problem is for the internet as a whole, the question is, while these private networks are flourishing, will the internet languish? Will it be left behind? Will transit for the rest of us no longer be viable? Will it no longer be low cost and high quality? The second problem is transitive peering. We know that the classical peering relationships of customer, provider, peer are transitive. That is, my provider's provider acts like my provider, and BGP itself is highly transitive. And this strongly affects how money flows in the internet. But the problem is that the flow of value is much more complicated than this. That value is created and consumed at edges, both in terms of content and ads. And so Fairton and al, their seminal paper, identified that we ought to think about this in terms of eyeball networks and content networks, and that's a more fruitful way to think about the value chain. And so there's lack of alignment between the transitive nature of peering relationships and the very different structure of the flow of value leads to policy tussles. Now, the most well-known of these tussles is network neutrality. And right now, network neutrality is at risk, and that's problem number 3. Network neutrality is a huge and an ill-defined subject. You can read several papers on network neutrality and not know that they're talking about the same problem. But at the core is best captured by Henning Schultz-Rennie when he says network neutrality is about money, not about packets. It really isn't about how to do quality of service or the engineering that goes into that. It really is, where does the money end up? And so if that's true, we should turn to economics. And the economics of network neutrality is far from settled. There are many different models. There are many different conclusions. And there's very little clarity arising from this literature. And on top of that, the enforcement of network neutrality is a nightmare. The internet is a global entity, but yet the issue of network neutrality or not is handled by a patchwork of local regulations. So for instance, in the United States, we don't have any federal network neutrality regulations, but some states like California do. And then we have Europe, which has different policies than the United States and different than other parts of the world. So here we have a problem where something that should apply to the internet more generally and more globally is being controlled by the patchwork quilt of local regulations. That's problem number 3. So we need both policy clarity, that is, we need to understand what the right policy should be, and then enforcement consistency. So the internet as a whole has a policy rather than it depending on exactly where you're communicating. So we must meet 3 challenges. First, to ensure the viability of the internet core, that is, all services should have access to high quality transit, not just those that are being carried on these new private networks. Second, we should align the flow of money with the flow of value, thereby creating what I would call an economic architecture of the internet that is as long-lasting as the internet architecture design. That is, we want to understand how money should flow just the same way you understand how packets should flow. And lastly, we should evaluate and then enforce network neutrality. We should have a much clearer analysis of what the right policy should be, and then a way to enforce this more globally. So our proposal in responding to these challenges is a public option for the core, a POC. This is simply a global nonprofit transit infrastructure. Each of those words is important. So this applies globally. This isn't just for a particular region. It's a nonprofit. It's not a charity. It's not giving its services away, but it is a nonprofit in that it has a mission, and that mission is to provide high quality transit everywhere. Transit, it is not providing last mile delivery. It is focusing on the backbone infrastructure. Now, we imagine that this would initially be based on leased bandwidth. Eventually, it could own some of its links itself, but that's not crucial in the beginning. We want it to start off without a lot of capital expenditures. Now, we would assume that last mile providers, LMPs, will attach to the POC for transit, and these could either be new access providers that are attracted by the POC or existing ones that decide that they want to use the POC for transit. And of course, there are other actors in the ecosystem. There are content and service providers. They would attach to the POC or go through an LMP. And then there are the users, the end customers, whether they're people or businesses, and they would attach to a last mile provider, an LMP. In deploying the POC, we imagine it being deployed alongside the current internet. It would be connected to one or more traditional ISPs, so it doesn't have to start off being global. It can start small and grow over time. And nothing changes for those who don't connect to the POC, that is, to the rest of the internet. A POC looks like another ISP. And there can be multiple of them interconnected. But here we will just assume there's a single POC. Now the POC changes the nature of infrastructure. That is, it goes from traditional interdomain routing, where you have BGP connecting all the transit providers and determining how things are routed, to a much simpler situation where for the POC and the LMPs that are attached to it, you don't have BGP, you don't have transitive peering. Instead, the packet flow just goes from an LMP to a POC to the destination LMP. So it's very simple. You also have a very straightforward structure of payments. The POC pays the bandwidth providers for the leased links. The POC also pays the ISPs it connects to for access to the rest of the internet. And then the LMPs and any CSP that wants to directly connect pay the POC for transit. As I said, the POC is not a charity giving its service away. We expect it to break even. And so the LMPs and CSPs that are directly connected would pay it for transit. And CSPs that are not directly connected and end users would pay the LMPs for access, both for sending and receiving. And here, it's important to note that what we're saying is that if the bandwidth usage on an LMP is too high, let's say, from streaming movies, then it's the users that have to cover that cost. That is, they're buying the right to get a certain amount of bandwidth, and that they would be responsible if the LMP is oversubscribed. And lastly, users pay the CSP for content and services. So what benefits does this fairly simple scheme provide? First of all, it makes sure that high quality transit is available to all LMPs. That's reducing the advantage of those with large private networks. It also separates access from transit, so the alignment of money and value can be better. That is, access is where the value arises, where it's consumed, and where costs are huge. Transit by itself doesn't create any value, and its costs are decreasing. So separating these out and having them charged separately is an important step in getting a better alignment. And lastly, network neutrality regulations can be enforced through the terms of service. There's no need for an international global agreement, but rather if you connect to the POC, you have to abide by certain network neutrality rules. Now, there are two technical challenges. The first is how to compensate bandwidth providers, that is, these, I'll call them BPs. They're the ones providing the least links. We don't want them spending a lot of time trying to figure out the market and how much they should bid and so forth. We want to make that fairly straightforward for them. And on the other hand, the POC being a nonprofit, you want to make sure that it's not playing favorites. So you want an algorithmic solution for how you compensate these bandwidth providers so everybody can see that it's fair. The second technical challenge is we want to model the economic impact of network neutrality. That is, what does network neutrality mean in the context of the POC? And is it a good thing or a bad thing? Now, for the first technical challenge, we want a strategy-proof auction for least links. Making it strategy-proof means that people just need to look at their own cost structure and decide, here's the minimum I'm willing to accept in return for using this link, and below that I don't want to offer it. And they don't have to worry about what other people are bidding because it won't affect the outcome. And the way we can accomplish this strategy-proof auction is we think of every bandwidth provider alpha offering a set of links with a cost function, and then what the POC does, it selects the lowest cost set of links, we'll call that set SL, that A, can handle the projected traffic matrix, because that's, of course, the minimum that you need to do, but also satisfies other constraints, like being able to still handle the traffic matrix under K faults or having enough geographic diversity or whatever other constraints you want to add. And then we use a standard VCG mechanism for the auction, and it turns out that the payment structure looks like this. The payment to bandwidth provider alpha is the cost of the links that we selected, that is the subset of L alpha that is in the selected link set, plus a bonus. And that bonus is the difference in cost between what would the minimal cost be if alpha didn't offer any links and the minimal cost when alpha is offering links. So everybody gets at least as much as their sort of bottom price, and they get a bonus depending on how critical they are in lowering the costs. That was the answer to technical challenge number one. For technical challenge number two, which is the analysis of network neutrality, we first note that there are many different ways in which network neutrality can be violated. And we don't want to sort of go through all these different forms of violation and consider them separately. We want to focus on the core intent of network neutrality. And the most basic violation of network neutrality is a termination fee. That is, that's where a last mile provider will charge a remote CSP, let's say one that's providing streaming movies, and say, you can't deliver your movies to the users on my network unless you pay me directly for that right. And if we allowed that, then the LMPs and the CSPs would negotiate some termination fee. And we want to look at the impact of termination fees in the context of the POC. And the findings for this model that take up a fair amount of space in the paper are any level of termination fees reduces social welfare. Social welfare is the sum of the utilities of all the users. And termination fees raise prices so users can buy fewer services, and that directly reduces social welfare. But perhaps more importantly, termination fees also favor incumbent LMPs and CSPs. That means in both the last mile market and in the content and service market, incumbents have an advantage over new entrants. That's an important finding that means that when you introduce network neutrality, you are hindering competition. So in this setting, it seems clear that network neutrality increases welfare and competition, and that result doesn't depend on any of the details or the size of the model. So given those benefits, we have to ask, could the POC ever become a reality? Is this just sort of a clean slate, white paper that's never going to have any impact on reality? Now, it could become a reality if the large CSPs collectively decided to provide an initial pilot. They certainly have the bandwidth. You could see how competitive it is with commercial alternatives. And if it starts attracting LMPs, then it could take off from there to become a viable standalone nonprofit and take off. So the question you might ask, well, why would CSPs do this? What's in it for them? Why would they make sure that this got started? And I have two words: fear and greed. Because their first incentive is fear. The lack of network neutrality is a real serious threat to CSPs. That if the last mile providers ever decided that network neutrality was not being adequately enforced and they could get away with it, they would start imposing fees for service or otherwise interfering with the delivery of services. So this is something CSPs would definitely not want to happen, and the POC could help prevent that. Secondly, the second incentive is greed. That is, there's a business adage, commoditize your complements. That means if there's some good or service that requires two components, A and B, it is A's interest that B become a commodity and therefore have lower prices, so A can charge higher prices. Well, internet services are something that require three components. Requires somebody to develop the service, a CSP, requires somebody to deliver last mile, that's an LMP, and it requires somebody to carry packets in transit, that's some transit provider. What the POC does, it makes both transit and LMPs less expensive, leaving more money left over for the CSPs. So there are serious incentives for why they might find this in their best interest. So a quick summary of the results. The internet's infrastructure is an accident of history. This is not like the internet architecture where we thought long and hard about how we should design the structure. The infrastructure, the structure, interdomain structure that we ended up with is really an accident of history. It has problems. The POC helps address some of these problems. In particular, it makes high-quality transit a commodity available to all. It also aligns money flow with the value flow in what we might call an economic architecture that we hope is as long-lasting as the internet architecture. And it enforces network neutrality through the terms of service. And lastly, it might be more than just a pipe dream. Just like network neutrality, the POC is more about money than about packets. And CSPs have strong incentives for making this happen. So with that, I'm done. Thank you very much for your attention.